Okay, hello everyone. So I'm back. So we were working on this algorithm to figure out where this unit can move within the map. After I left last time, I thought I would make some modification to the function that I made, and we have to improve it. So first, at the end of the thing that we did last time, which is making a left turn, and it gave us more than 500 options. I think I forgot about this rule that I said last time that someone should bring this up. So don't end with TR or TL. Always end with MF. So basically, we are not bringing any rotation at the end of the movement. That means I would still push this previous path plus TL, but I am not gonna push this bunch to the path so that it will keep running, but it wouldn't add to the final path that we're gonna make. So it's going to save us some options, and I'm gonna just make a shortcut here and do call path at init. And if I reload, it's gonna just automatically run this function, and it gave me what 264 arrays already. That is because, so if this is the endpoint, he's gonna just make this path, and he could just make this path, or he could just make this path to get to the same position. But we just want to keep the option that requires the minimum movement for him. That means the path that consumes the least point. That's what I mean. So I'm just gonna filter whatever that goes to the same spot at the end and take the path that takes the least amount of points. So every time we figure out next tile is found, but if the next tile is already in the path array, and if it takes less points than the current path that this function took, then it's not going to push it to the final path, and at the same time it's going to just quit calculating because there is another path going to the same spot, so it's already figured out starting from there. So what I'm going to do is find, so let's take all the path and find the position x equals to next tile x, and y equals to y, and z equals to z. Right, so this is it. So if I find this path already, then let's compare that path and what's the parameter? Consumed points, right? Path consumed point is if it's less than the consumed points that's of the current path. So what's consumed points total plus consumed points, right? So this is the number, right? So this is the number. If the current consumed points, consumed points of the current path is greater than the one or equal to, I would say. Where it's equal, then just get rid of it. Return true. And everything else is false. So let's check if previously visited
equals to path, and instead of finding, let's get just sum. So it's true and false. And if it's true, return. No, it should return the path and end there. So let's see how this can reduce the calculated results. Instead of having 245, okay, right, so now I'm getting 23 results. It's likely that this is good. Consent point. Okay, I don't know, it looks like it's working okay, exactly the way I thought I would. Oh yeah, even if you're starting from here, you can make turns and go to a different spot. So I'm just gonna visualize this, and actually I'm gonna enable the right turn as well. So I'm just gonna copy spot. Okay, so how many results do I get? I got 54. Okay, so it kind of, okay, so there'll be 54 tiles somewhere here that this guy can move. I'm just gonna visualize that. Well, after I worked on this function, I will work on the refactoring of it because it's kind of messy now, and I have some idea how I should refactor the whole thing. Let's see, just get rid of all the console thing, console log. Okay. What I'm gonna do is unit clicks. After find path is done, take this path and find. Okay, so I should actually name each tile. So how do I do it? So just return an ID. I'm just gonna let count and ID is count. I'm just gonna do this after pushed count. Okay, count and save it, and then go to the tile definition and add an ID that is a number. Every tile would have an ID, and I'm just going to add that to plain ID equals to tile.id. Then we can find the ID, right? So that's marked, and also let's go to the algorithm that we just made, find path. Okay, so I'm just going to push an ID of the tile ID. Next tile.id. Not here. Push, yeah, this is it. Okay. Tile ID. Next tile ID, yeah. So I'm just gonna copy that. Well, that's it. I mean, this is the only time we push to the path, right? So it's done. And so taking that ID, okay, so path for each path. So it has, I'm just going to stop here and do the calculation again. Okay, so initial tile, and the result, well, it's 40 now. So result would have the final position, right? And then the tile ID, right? Yeah, 35. So for each, right? Let L is document get element by ID, path tile ID. So let's log it so that we know it exists, and that's right. This is exactly what I was trying to do. He knows. Okay, so set attribute material. Let's get. Okay, so how many 12 path. Why? Yeah, because you have to turn, because the going forward is not working, so you have to make a right turn, and then yeah, it's good. But why is this like these spots are marked red as well? Let's see. Somehow, A-plane ID 0 is 0 and 4 are selected. Let's try another shot. So 0 is again selected, and okay, so what it's doing is, okay, so going forward is working, and then going right is actually working, and going backward is also working. So yeah, why is he not going to the left at all? And why is tile 0 always selected? So the high spot, I mean, you can't really reach it, so that's why it's kind of locked out. And also this spot is locked out because there are too many gaps here, so that's working correctly. Why is tile 0 always marked? And why is he not going to the left? Oh, there's no east here. Okay, that's why. Position X increases when you're facing east. This is it. Okay, now let's go. Ta-da! Okay, now it's looking really interesting. So very high spot is removed, decrease. Okay, so yeah, and then all the tile IDs are unique. It looks like, so it's not really. Just gonna look at it in the wrong view. So are these unique? All of them? There's no duplicates, right? It looks like it's working. I don't really see any duplicates, do I? 121. Well, yes, I do see some duplicates, so there are some duplicates. 121 and 102 is also double. So there are two paths that goes to the same final destination. Okay, so since I have the tile ID already installed, so let's get this matching tile ID. Next tile ID. Just get rid of this and just make an and comparison. Get rid of this. Then pass some points, points. It's still doesn't really return true if the constant points. Oh, I see what it is. So if the constant points total is actually less than the existing ones, it doesn't really remove the previous one. I see. So if okay, so I think I did it wrong. So So this was right, and if this was taking more consumed points, then return true. But if it's not, then remove the path. Path, filter, path. The tile ID isn't next. Okay, so filter. Let's do it again. Path. The path tile ID is the next tile and ID. So we will remove that and push that later. Okay. So this was needed, but then no, this logic had to come where and return false, isn't it? So that's what it should do. I'm just gonna leave it as is. Okay. So yes, so this is looking good. Going backward straight is quick, but going backward and making turns, it takes some time. Okay, so it's looking good. Some high point cannot be reached. That's good. And how many tiles are there? So, and then are these unique? I can just check it, but I'm just gonna look at it by eyes and judge it. Looking good, right? There's no duplicates. I believe. Maybe I will just draw out the path that it's gonna take. But I don't know, maybe not. I would assume it's working. So this like figuring out the path is critical in the game engine that I'm making, because if you look at the tactics ogre and how they are doing, they don't actually calculate the path. They would just judge the tile property, but going forward and going backward would take the same amount of effort in this game. But I want to change that because I wanted to make it more like a chess play where one move can lead, well, moving and the positioning of each character is very important to win. So if you go forward, it's harder to come back. That's what the chess and shogi, that's a Japanese chess. That's what it is. So right, so going forward should be easier than going backward. And taking which path should be also important, because I want to make a feature where if you walk right next to your enemy, you get intercepted. That's kind of the feature that I want to add later, so that figuring out the path that it's going to take is important. And also when I would work on the AI to figure out the best path for the non-player characters, so some of the path should be marked as dangerous path if it's going right next to its enemy. So there's a choice to go to the danger path and safer path. So that's why I'm kind of spending a lot of time tweaking this algorithm at the moment. So I might actually want to draw out all the paths in lines here, but I think it's good for now. I assume it's working. If there's some path that's taking, yeah, it's looking actually very good. And now I don't have the zero filled out at all. Okay, so yeah, this is looking good. I think I'm just gonna pause for today, and I think I'm gonna work on the refactoring late afterward. So that's the next think I would do. All right, thanks. Bye.